Alright, so we're going to a bunch of help questions here that I'm going to try and work my way through. These are from 25G to start off with, and we'll see how far we get. So wind tunnel experiments on a new aerofoil indicate there's a 98% chance of the aerofoil not disintegrating. Doesn't sound too flash. In a sample of 100 aerofoils, use the Poisson distribution to determine the probability that 1, 2, or at most 2 disintegrate. Now, you're probably thinking, why would we use the Poisson distribution for this? Because really, this is a binomial distribution, and we should all be pretty comfortable using our binomial distribution to figure this out. In an exam, I would expect you to go with the binomial. So let's have a think about how we'd do it using the binomial, and then I'll show you what happens with the Poisson as well. So here we go. A sample of 100 aerofoils, determine the probability that only one. So the probability that 1 disintegrates is 0.02. We've got a sample of 100. So this is perfect case for binomial PDF because it's one specific value. Get my joke there? Yes, we all know it's specific, but a lot of people don't. So that's a good way to remember it anyway. So we go to a binomial distribution, and it's a probability distribution. That's what the PD stands for. So binomial PD. We've already put our P and our N, and we want the number of successes to equal exactly 1. Successes or failures, just depends on how you define them. Works the same way. So here we go, into our menu, number 2 for stats. It's a distribution question, binomial distribution. I want to know for one specific value. It's not in a list, it's a variable. Don't feel like typing out a list to 100. I want to know exactly 1 failure. Number of trials is 100. The probability of a failure by any one is what is it? Aerofoil, not hydrofoil, aerofoil, is 0.02. We can go ahead and calculate that pretty easily. 0.2707. So the probability x equals 1, or number of aerofoils failing equals 1, is 0. Whatever we had before, 2707. And that's not too bad, is it? So there's our first one. Only 2, going to work exactly the same way, except we do 2. At most 2 will disintegrate. You know, this time it's up to and including 2, so we just exit and do our distribution as a binomial cumulative distribution. And we want to know up to and including 2 disintegrating. We can go ahead and execute that one, and we've got the answer. So 0.6767 if we use a bit of rounding there. 0.6767. Obviously you'd use a bit of communication, show everything that you do, but that's how you do it using binomial. So what about the Poisson distribution? How are we going to use Poisson to find the answer for this one? And I must admit, this one had me a little bit confused for a while because it's so obvious to use binomial. Why would you be using Poisson anyway? But let's go ahead and do it. Now we're dealing with a sample of 100, but the way we can work around this is we say, well, in our sample of 100, if 2% are going to fail, then the expected value, the mean value, is going to be 2, isn't it? Now how many are we actually looking for out of that mean value? We want to know what's the probability of getting exactly 1. And they're the numbers that we use in our Poisson distribution. So if we go to distribution, and we scroll across till we find Poisson, one particular value, so PDF, it's got to be a variable. We want it to be a variable. Now, I'm only looking for 1 when the expected number, in however many I'm doing, in this case it was 100, so I know the mean value that I'm expecting is 2. If it follows a Poisson distribution, this is going to tell me 0.2707. So probability x equals 1 is 0.2707. Very similar statistic, isn't it? Oh, except that I wrote it 2 instead of a 7 because I'm strange like that, and now I can't see where my cursor is. There it is. All good. Let's get rid of that. Doesn't want to get rid of that. Too bad. I can cheat. There we go. Turn the pen upside down. Alright, so what about at most 2? So if I want to get the same calculation that we have here, how do I get that calculation again using my calculator? Well, we just exit. So go back to our distribution. Scroll across to Poisson. Now remember, this one says at most 2. So we want up to and including 2. So it's a cumulative distribution. So we use the C. Here, x is 2. That's up to and including 2. The expected number is 2. What happens when we execute this one on our calculator? 0.6767. There you go. So we're getting the same answer. So you could do it either way in the exam. Usually if I can see 2 alternatives and a number of trials, I'm thinking binomial. Poisson is for how many occurrences within a certain period of time. Pretty similar. They both work. Hopefully that makes that a little bit clearer. We'll have a go at the next question in the next video. Cheers.